Good morning, everybody, and welcome back to Next Door Net Admin. I've had an interesting conversation on my original PXE boot video in this last week with DK42432, and I realized first off that some people have seen errors where their PXE boot is looking for specific files that are not included there. I see the same log messages, but it doesn't seem to prevent me from doing any PXE boot. It looks like it's just looking to see if those files exist. Um, and if you've run into an issue where it won't boot without those files, I'd have to do a little more digging before I figured that one out, because not having those files isn't disrupting what I'm doing at all. But part of the conversation was it looks like it takes a longer time to boot from the setup that I have with dnsmasq than it does from something like Windows deployment services. And after digging into it a bit, we found that that's probably down to RFC 7440 support, which added an option called window size. For those of you who aren't aware, TFTP at its most basic is a one packet protocol. The server sends one packet, the client has to acknowledge it. The server sends one more, the client has to acknowledge it. This kind of back and forth is what slows it down a lot. So with a window size, you can send 8, 16, 32 packets from the server and wait for one acknowledgement. And then you can send another stream of packets and wait for one acknowledgement. This is a feature that Microsoft apparently came up with and put in Windows deployment services back in 2008 R2, and it became a full RFC spec in 2015. But there's not a lot of servers outside of Windows deployment server that seem to support it. dnsmasq does not, or has not. And TFTPD-HPA seems to only have a patch available, which you can patch in and recompile it to add support. So, with all that being said, out of curiosity, I did some research on RFC 7440 support in dnsmasq. It doesn't have it, like I said. But I did see that somebody had raised the possibility of it and asked Simon, the lead developer of dnsmasq, if it was on the roadmap, and he'd said no, it's really not. But I emailed him and I asked him, I said, has anything changed in the intervening span of time? Because I've kind of got the same use case as the other guy, and we conversed back and forth, and I said, well, I mean, I can see Tiano Core seems to have support for it, so open source UEFI implementations do have this functionality implemented. And here's my use case. I'm trying to avoid using Windows deployment server, but I am booting Windows PE. I'm just doing it without all of that nasty infrastructure. And here I could also use it for transferring large iOS images for Cisco switches and such. So, there's more than one use case for it. And to my surprise, very much to my surprise, because I was not asking for this, this morning I got an email from Simon that said, okay, you've piqued my interest. And I had, some spare time while I was waiting for other things. And I happened to have a fully charged laptop too. So to my utter surprise, he's put together a version of dnsmasq which does have RFC 7440 support. And he's asked me to test it to see if it works. I have not done this yet. You're about to watch me do this. dnsmasq itself, if you're at the website, And if you browse the the repository, you can see that at the time that I'm recording this, this was just added literally 5 hours ago. And then there was one other bit of work, and then this is tagged version. It's kind of small, so I'm going to read it out. Version 2.92 test 10. Okay, so this is a possibility now. If I go to download it, it's not in any of these. So I'm going to go down to test releases at the bottom, and I'm going to look for 2.92 test 10, which is right here. There's a tar in gzip and one in xz format. But these are going to be source code. These are not going to be actual compiled releases. So I'm going to have to do that myself in order to test it and see if it works. If I start, test 10, okay, good. Just making sure I've got the right file here. I've got a virtual machine that I just put together. It has the same version of Ubuntu as the main PXE server that I've got, so that I can compile this properly. The only thing I've done here is I've installed the package build-essential, which includes the compiler, make, all the bits and pieces that you would expect to see. I'm just going to wget that particular file. There it is. All right. And I am going to, first thing I'm going to do is just ls this to make sure I know what's in here. Nothing at all. Okay, cool. tar-xvzf dns. There we go. All right. So now we have folder for that. Okay, I'm just going to remove the tar file so that that's less hanging around. Go into the folder, and if I ls this, we've got a make file, we've got a source folder, we've got some of the other stuff, including changelog, the copying, the FAQ, the version, etc. At this point, honestly, I'm just going to jump right in and try making this. I'm going to use the all I18N. If you don't know what I18N is, it's short for internationalization. It includes all the locale files. But nobody wants to have to type out internationalization. And there's 18 letters in between the I and the N. So we just say I, the number 18, N, so that you don't have to type out internationalization. Something similar happens with localization, and that because there's 10 letters in between the L and the N, that becomes L10N. Programmer shorthand, apparently. I have not actually compiled anything for years and years and years, so this is going to be interesting to see what happens here. All right, so we are making a bunch of stuff. Cool. Whee! All right. I see then we got a bunch of errors here. Okay, but that's just because we're going into various directories and seeing what we have here. But we got all of these compiled up. Not 100% sure what happens with all of that, but we definitely did compile all of this stuff. And if I go and take a look at what we've got here. Yeah, so apparently if I go into source and take a look at what we have here, we have a bunch of C files. We have O files, which is the output or object files. H files are header files. And like I said, C are C files, it's actual code. We have an actual executable here now. Very good. All right. So I should transfer this to my main PXE server. and then start up the Windows test VM that I have so that I can compare the load time on these, and we'll see what we get. Excuse me while I do that. Okay, then. I've copied the new executable over to my Pixie server. I haven't replaced the old executable yet because I want to do a comparative boot test. So what I'm going to do actually is I'm going to pull out my phone and I'm going to use the timer on it to see, or the stopwatch rather, to see precisely how long it takes to load the WIM file, because that's what we need to take a look at. So let's start this. There we go. All right. And yes, I know that this is in a virtual machine and it might take longer to transfer in real life, but in real life, this is real life. It might take longer to transfer on actual hardware, but this should at least give us a decent benchmark for what kind of improvement this may make. I clocked that at about 28 seconds. So let's go ahead and turn this off. All right. 28 seconds. Okay. So let me pop back over to my other VM for just a moment here. And I need to remember that I need to shut off the service first before I replace it. I'm going to change dnsmasq to dnsmasq.old. So I'm going to do that with sudo because otherwise it complains like crazy. All right, and then I'm going to start it. No, huh? Well, there you go. It exited with an error code. So let's see what the error code was. Possibly something else changed in between. That doesn't tell me exactly what happened, so let's see here. I'm not going to keep you watching the entire time just because that'll get really boring, so 1 second. All right, so I think I've got something figured out here. When I am trying to start up the service with the newly compiled version of dnsmasq, the part that's actually failing is systemd does a check config on the configuration file first to see if it works. That's the part that's failing. I don't know why that part is failing, but it's saying there's something on the command line that doesn't belong there. Okay. dnsmasq on its own looks at our options, doesn't have any problem with it. So for the sake of testing, I'm really just going to try and run dnsmasq on its own. I'm not going to daemonize it. I'm just going to have it run in foreground so that I can see what it's doing. And these are all the same options that we have here. Port 0, we don't need DNS, log DHCP, DHCP range, no override, enable, TFTP route, and PXE service. Cool. The only difference being I've put this one in single quotes because there's spaces in that and I need it to process the entire thing. Fun thing, I tried it without the single quotes first and it told me junk on the command line. And I'm like, junk. Okay, sure, fine. But if I do this, it's started, it's running foreground so that we can test it. 2.92 test 10. Cool, great. Let's see what we get when we test it out, because that's going to be the interesting part, isn't it? All right, got to make sure I have my stopwatch ready here. off you go. Oh, wow, that is much faster. Holy crow. And it's done. That was 6 seconds. That was 6 seconds. What did I say before? 28? It went down to 6 seconds. Woo! Okay. All right. Wow. I'll tell you, I knew it was if it was successful, it would be a substantial improvement. I still to watch it go, I'm like, ooh, that's a lot faster than I thought it would be. Wow. Okay. I'm all right with that. Okay. And we can see that it did exactly the same thing. It caught it and it did not find those files. That's fine. It did send it and went shoo. Wow. Okay. All right. Very cool. I suppose. Yeah, I was busy reading about how to do your no dame and get it in the foreground there. If I get rid of that. If I do this, so in my BCD, these are the options that I changed there. TFTP block size 1468. You can find suggestions to set that even higher, but when I was looking at the code for dnsmasq, I can see that it's going to take your MTU, which for most Ethernet networks is going to be 1500, and it's going to subtract the size of the headers for IP, for UDP, and for TFTP itself, which is a total of 32 bytes. So if you set something larger than 1468, you're going to get 1468 out of dnsmasq anyway. Period. That's just a fact. So I have it set to 1468. I could put it bigger and it wouldn't make a difference. But if I ever switched to something other than dnsmasq, I suddenly might have problems and I'd have no idea what caused it. So being conservative about this, I'm just going to put it at 1468 and let it be. RAM disk TFTP window size, 16. In RFC 7440, they did some testing and the curve kind of looks like this, where as you start increasing the window size, your time required drops dramatically, but then it curves, and past about 16, you don't get a lot of benefit. They tried it at 32, it maybe saved 1% time. And at 64, it didn't save much more. It saved like maybe another 1% of time. So the benefit tails off relatively quickly past 16, a window size of 16. But having looked at the code in dnsmasq again, it caps out at a window size of 32. So 32 would be the maximum, and again, beyond that, you really wouldn't see a major difference. 16 seems to be the sweet spot for getting an appreciable gain out of the process. So those are just two additional settings that I put into my RAM disk options. And as you can see with the new version of dnsmasq that's currently in testing, it made a substantial difference in speed. So that's actually kind of exciting. And I'm looking forward to getting this into production. at some point, and running more tests with it on actual hardware, because hey, a virtual machine is one test, hardware is another. So I guess we'll see on Monday how this changes. And yeah, this is cool. I'm really happy about this. So there you go. You got to watch me actually compile something from source code and do a little bit of fiddling around to figure out why it didn't just slot in the way I wanted it to, and then test it. And boy golly, did it test out all right. So I will let you all go for now. Hopefully you found that interesting and exciting. Send Simon some love for dnsmasq, because dnsmasq is one of those tools that is everywhere, whether you see it or not. And he deserves some thanks for that. And so, I mean, go send him some love. Yeah. Hopefully that's exciting, that you'll get to see that feature in production at some point in future as well. But otherwise, if you have any questions for me, if you have stuff that you'd like to see me talk about, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door netadmin, and we will see you next time.